Hey, this is Mr. Aiden. This is Pre-Calculus Honors. We're going to be doing limits at infinity of quotients, okay? Since for the longest time we've been doing limits at a certain number. What's the limit as x approaches 2 from the left? Or what's the limit as x approaches 2 from the right? But now we're taking a look at what happens as we go towards infinity. Our last video, we took a look at limits at infinity of graphs and what was happening as we go towards positive infinity and what happens as we go towards negative infinity. So let's take a look. All of this depends on one thing, one kind of rule that I can live by, which is we hate Dallas Cowboy fans. Sorry. I am an Eagles fan. Not as much to do that to a house, but I respect the little girl. The one rule we got to live by as we're looking for what happens as x approaches infinity is understanding what happens to the function 1 over x. As this x value gets larger and larger and larger and larger and larger, as we go from 1 to 2 to 4 to 10 to 100 to 1,000 to 10,000, we keep getting smaller and smaller and smaller. This is what we call an inverse function, isn't it? Which means the limit as x approaches infinity is equal to 0 for this function, because as we continue to go towards infinity, we're getting closer and closer and closer to 0. This is the key to knowing all of these limits at infinity. Now keep in mind, we're only doing limits at infinity here. And so I'm going to describe the first one for you of what happens. You can see how we have a function. We have a quotient. We have 6x squared plus 5x plus 3 on the numerator. We have 4x squared plus 8x plus 4 on the denominator. Now, if you can see, this is kind of a difficult function. Okay, it's really difficult to factor. It's really difficult to do a bunch of different things. And we're looking for what happens as this x approaches infinity. So what we're going to do is this. We're going to use the concept of this. We're going to divide every single thing by x squared. So every single thing in every single part of this equation is going to be divided by x squared. Why? Because that was the largest exponent we could see. So what's 6x squared divided by x squared? I'm actually going to write that. 6x squared divided by x squared plus 5x divided by x squared plus 3 divided by x squared. That was my numerator. My denominator, we had 4x squared divided by x squared. We had plus 8x divided by x squared plus 4 divided by x squared. So what happens? What's 6x squared divided by x squared? We get 6. What's 5x squared divided by x squared? That's 5 over x, isn't it? What's the next one is 3 over x squared. Okay, that was my numerator. My denominator was 4x squared divided by x squared. That's 4. What's 8x squared divided by x squared? That's 8 over x. And our last one is 4 over x squared. Now remember, what are we doing to this? We are doing as the limit as x approaches infinity. So as x gets closer and closer to infinity, what happens to this number right here? This approaches 0, doesn't it? What happens to this number right here? This guy approaches 0. What happens to this guy right here? This approaches 0. What happens to this? This approaches 0. And what are we left with? We're left with the limit as x approaches infinity of this function is 6 over 4 or 3 over 2. And that is my limit. If I graph this guy out, we would see graphically that this is correct. Take a look. This graph of 6x squared plus blah, 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 over 4x squared plus blah, 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 you can see how we are approaching, as we approach infinity, we're approaching 1.5 or 3 halves. 3 halves. So our algebra looked correct here. Now, if you want a simple way to do this, if you see that the highest values of the exponents are the same, we can cancel everything out. Remember, only when the limit as x approaches infinity, not when the x approaches a number, okay? But when x approaches infinity, and we're left with our coefficients, 6 over 4 or 3 over 2. Now you might say, Mr. Aiden, what happens if these exponents are not the same? Well, that was the very next thing I had up for grabs right here. Okay, so what do we do here? We're going to divide everything by x cubed. So we're going to divide everything by x cubed. You can see the numerator's exponent is larger than the denominator's exponent. It's x to the fourth, whereas the denominator is x to the third. And so what do we have here is we have 5x to the fourth over x to the third plus 3x to the third over x to the third plus, minus 2x squared over x to the third plus 3x over x to the third plus 5 over x to the third over 2x to the third over x to the third plus 6x squared over x to the third minus 2x over x to the third plus 3 over x to the third. Now remember, what are we doing here? We're taking when the limit of x approaches infinity, which means you can see anything with these denominators are going to equal 0, right? Because as the denominator gets bigger and bigger and bigger, this all becomes 0. So this guy is 0 here, this guy is 0 here, and this guy is 0 here. And what are we left with? We're left with the limit as x approaches 0 of 5x, because we had 5x to the fourth over x to the third, plus 3 over 2. Now let me just ask you, if I took this x, and he got larger and larger and larger and larger and larger all the way up to infinity, where would we be? Positive infinity, wouldn't we? Positive infinity. Or you might say that the limit does not exist. Okay, because it is not bounded. It is unbounded. It's not bounded. Okay. If I take a look at this graph, let me take a look at this graph right here. You can see as we keep getting further and further and further towards infinity, you can see how he's going towards positive infinity, isn't he? He's not being bounded. He's not bound by anyone. Okay. And so you could say anytime your exponent is larger on the top then your denominator, the limit is always going to approach infinity, or you could say does not exist because it is not bounded. Not bounded. Okay? Now, what's the last question? The last question is what happens when the denominator has a larger exponent? See how the denominator says x squared? Okay? So now, let's divide everything by x squared. So we're going to divide everything by x squared. So let's take a look at the numerator. We have 2x over x squared minus 3 over x squared. The denominator, we have 4x squared over x squared plus 3x over x squared minus 5 over x squared. And remember, we're doing the limit as x approaches infinity, which means, take a look, anything with a larger denominator on the bottom is going towards what? 0. X over x squared, you're going towards 0. 5 over x squared, we're going towards 0. We're going towards 0. And what are we left with? We're left with 0 on our numerator, and on our denominator, we're left with 4. What's 0 over 4 the same thing as? 0. So the limit as x approaches infinity is equal to 0. Let's take a look at this last graph. This last graph works, doesn't it? Do you see how? You can see as we approach infinity, we're getting closer and closer and closer to an asymptote of 0, aren't we? And so anytime, you could say, anytime your denominator has the larger exponent, it is approaching 0 because this denominator is getting higher and higher and higher and higher numbers faster. The denominator is getting larger faster than the numerator, so it's getting closer to 0. Which means, as a summary, if the exponents are the same, the limit is just your coefficients, a over b. It doesn't matter what is ... doesn't matter. If your numerator's exponent is larger, it's the limit is of positive infinity or infinity, and or you could say does not exist because it's not bounded. And then what happens if the denominator is larger? It equals 0. And keep in mind, this only works as we do the limit as x approaches infinity. Okay? That is my limits at infinity of quotients. So it just sounds more interesting when I say it that way. All right. Do your self-assessment. Catch you on the catch ya. Bye-bye.